Hi there, Darren here. Hope you're doing well. Within this very quick tutorial, we're going to be jumping into using the heat transfer simulator for U values and even to generate psi values. So let's jump straight into it. So here we are back in the heat transfer simulator, and I'm going to clear all here, and we're going to start looking at the subject matters of U value and PSI value. Okay, so let's go to U value first. So obviously, if you're looking at U values, you know what they are. They're about the thermal transmittance of the wall system, and we can go ahead and add materials on with their respective boundary conditions in order to ascertain what the U value is. So let's go ahead and undertake a couple of simple exercises. So I'm going to grab the draw rectangles tool here. I'm just going to zoom in a wee bit, and I'm just going to snap to that corner there, and I'm going to pull a shape around. I'm going to call it 200 by 200. That's fine, and I'm going to do that a couple of times. Okay, make it 3 times. Okay, and for all of these blocks here, we're going to select a different material. So if I select the block there, I can see that this one has a default material. I'm going to change it to something specific. Let's call it concrete. Okay, so the first one's concrete. Second one, what should we call it? Let's call it EPS. And the third one, let's go ahead and call it something with a low performance. Let's call it zinc. So a big block of zinc. Okay, so we've got zinc, we've got EPS, and we've got concrete. Okay, so now what we're going to do to use the U value tool in order to assess what the thermal transmittance is across this detail here, we're just going to need to run a simulation. So we're going to set boundary conditions for all of the 3 shapes. We're going to select our assign boundary condition tool, and we're going to select interior horizontal and apply that to the interior being down in this example. We're going to add exterior, and you may want to choose specific boundary conditions for this. I'm not going to get wrapped up in that. I'm going to go ahead and turn off those there now, just so we can make a bit more space. And then, should you wish, you can go ahead and run a simulation now. And it'd be useful to run a simulation because you can see the relative difference in isotherms as you do. I might just actually do that, why not? So we're running a simulation for all 3 at this point in time, and we'll see the divergence of isotherms with the central one there, with the just behind the calculated heat transfer, having quite tight isotherms running parallel across the block, and then zinc over to the right, which has the poor performance, having a very wide distance, or a large distance between the isotherms. And over here we've got the concrete normal, which is something in between. So this starts to give you a feel for what's actually happening with the materials. I'm going to turn off that and go back to the subject matter that I'm intending to talk about, which is the U values here. So if we want to look at U values, we select the U value tool, and then we can go ahead and select a point on the outside, a point on the inside, and we can then get, let's call that EPS, right? And hit OK. Now once we've got this, we can start to see we have a 200 mil length that has been taken into account, happens to be on a 90-degree path. It's EPS, that's the only thing that's in it, 200 mil of, with conductivity of X 0.033. That gives us an R value of 6.06 based on the exterior surface boundary conditions of 0.13, and in 0.13 on the inside there as well in this example. That 6.32 converts over to 0.1582 based on a 20-degree difference between inside and outside, which equates to that heat flux value there. So there you go, that's how you get a breakdown, a very quick result there in terms of the U values. And you can go ahead and obviously repeat the process. Go and have a look at the same for the zinc. Oops, let's go ahead and correct that. Hit OK, and of course we've got exactly the same thing, except we've got a conductivity of 112 as opposed to 0.033. So we result in an extremely low R value and a extremely low U value. So really, really useful to get a feel for what's happening in your system. And let me just, what did I not do there? I just select this point over here. I had the wrong tool selected. So I'm going to go ahead and select that there, and that was the concrete. There you go, hit OK, and we get the same once again, this time with the conductivity in 1.4. Same boundary conditions, of course, and you get the resultant R value and U value. So there you go, that's a really quick introduction to how you can get U value measurements directly out of this tool, and I hope you find it really useful. Next up, we're going to jump into psi values. I think that's the way it's pronounced. All right, thanks a million. Bye-bye.